canter through some of this. And I promised to sort of come and talk about electronics and electricity and how that is going to underpin the move to the clean, green, and exciting future that we want for this world. And I was going to sort of give you a little bit of background on me, a little bit of background on some of these areas, but also where do you fit into this? Where can you, with the joy and love you have for different things now, actually have a part to play in this future? So who am I? Well, I am currently a very big title. I'm Challenge Director for Driving the Electric Revolution. So this is a government initiative to try and grow what we're doing here in the UK. So UK activity around electronics, around electric machines, around starting to invest in companies to do this exciting research. So I'm funding a portfolio of projects there, a range of projects from big companies. We've given money to the likes of Rolls-Royce, through to some small companies that are just starting up. So it's really trying to foster, you talked about getting the next new idea, and how do we keep working with those companies? So at the moment, my job is, rather than sat at the bench with a soldering iron, is very much about working with organizations to take these great ideas that people have. And hopefully some of you out there have got some of these great ideas. How do we do those? Turn them into successful businesses and invest in this technology. But I came into that role from working as a global consultant. I spent my time traveling around the world. So if you're interested in being an engineer and you want to go and see different parts of the world, the two definitely go together. And I spent my time at a consultancy called Ricardo, doing a lot of work mainly around hybrid and electric vehicles, but generally around clean green technology using electronics, motors, generators, ranging from wind turbine activity, rail, marine, and electric cars. Before that, I worked as the third employee in a very small company. So I've gone from a company, at the moment, we have thousands of people. Ricardo was about 3,000, and I was employee number 3 in the first job I took. So across that range, and that was again developing converters for wind turbines, clean energy. At the moment, I'm a visiting professor at the University of Strathclyde. So I go up there and work with the academics. I keep in touch with the latest technology. And prior to that, I did my PhD and degree in the University of Bristol. So I've travelled around the country, and as I say, I'm now based just outside Hertford. So that's a little bit on me. I'm not putting myself in the same league as these, but these are sort of the 3 pillars. When we talk about electrical engineering, everyone's heard of Tesla, mainly from the electric car. But I certainly know that in the primary curriculum, they're sort of looking at some sort of key scientists, historical scientists and things. And these are probably, for me, the 3 big ones in electricity. We're not going to go into details of the life and times of Michael Faraday. I think I would struggle on that, let alone all of you out there. But I think it's important. These are the key people who are involved in, I'm going to say inventing, they're not inventing, but discovering electrical properties. And I think some of you may well have come across these people, albeit not in picture form. Alessandro Volta, the volt, so the measure of electrical potential. Andre Marie Ampere from the amps, and James Watt from the calculation of power. But these people, once we look backwards at great people from times gone by, it's now, it's us. How can we apply what they did back then now to solve today's world problems? And the first one and the biggest one, and there's some clues in the picture with us, is around that clean green electricity generation, moving away from coal, oil, gas generation into wind, tidal, solar, nuclear. There's been big announcements recently around small modular reactor activity in the nuclear space, all of which are zero carbon technologies. And anything we want to do, we need the zero carbon electricity in the first place. And just picking on the wind turbines, I think these are quite interesting. What do they contain? Well, Inside what you see there, there's the blades. And those blades, touch on how big are they? The biggest blades in the world now are 107 meters long each. So you're looking at the total size of that sort of circle the wind turbine rotates in excess of 200 meters for the latest generation. But there's also the electric motor or generator in there, which contains magnets, it contains copper. It starts to then become the electrical system. But the wind doesn't blow at the same speed all the time. So we've also got some electronics in there to mean that you and I can go and plug in the switch, our TVs, the iPad, so that we can use that electricity for what we want. So we've got electronics there to control that. And they work with this interaction from the work from Michael Faraday that we saw earlier on, interaction of magnets and coils. There's very little I'm going to sort of say, please trust me. But if you move a magnet through or a magnetic field through a coil, you produce electricity. That is how these things work. That is the same way that we've been producing electricity in our power stations to date. But that is where there is a huge amount now of activity in growing wind turbine technology, pushing the boundaries of what is possible there. But it's also how are they anchored? There's a lot of work now. The ones you see here are secured to the floor of the seabed. We're now looking at floating wind turbines. So we need a lot more civil engineering, a lot more structural people. So whilst I'm an electrical engineer and I clearly think this is the most exciting part of engineering, I am a little biased on that. But there is a huge range of bits for everyone. And the future, well, we're growing in size here massively over the last 20 years. Are they going to keep getting bigger and bigger and bigger? We're seeing more and more and more of them. How do we get them more efficient? How do we get them so that they're there to make the world a greener, cleaner place? So have people got ideas on what do we do at the end of their life when they're finished with? How do we make the materials within them in the first place? Possibly more exciting one, electric vehicles. They're here to stay. There's everything ranging from the Formula E series, so looking at that racing end of really high performance, all the way through to cars that we can buy today to start to replace the combustion engine cars. And there you can see this is a gearbox from a car. You can see the electric machine off on one side. So this is the motor here that's going to drive the wheels, and it goes through the gearbox and then comes out to drive that. So how do we design that electric motor? How do we control the electric motor? And that needs electronics. We can't just take a battery and plug it into a motor. We're going to need electronics, and we're going to need more and more sophisticated electronics. And within that, I would have thought a lot of you out there really enjoy gaming, enjoy playing on a Switch or I'm digging myself a hole here on your iPads, on anything like that, where you're working in these sort of game type things. Well, the software that's used to develop those games is very, very similar to what we need to control these electric machines. The more advanced it becomes, the more accurately we can control these, the more efficient. Now, so if you love gaming and think, I want to write software like that, it's not just relevant for that game. You can start to use it in other areas, but using the same techniques and the same love of software engineering. I say the electronics is unbelievable now. If you plug your tablet into charge, there's normally a brick, a plug, looks something like this, that's got more. It's not just a plug. Inside there is electronics and power electronics that are going to control things. Huge market for that. And it ranges from that to dishwashers, to washing machines. Maybe our audience are less familiar with the use of a washing machine, but we can get all of those everyday things need to be more efficient, and they need ideas for the future. How can we do them better? we carry on doing things the same way until somebody goes, hang on a minute, why are you doing it like that? We always have done. We need to start to stimulate new ideas. Same in robotics. We can see here picking fruit, and they're tomato plants being picked and harvested by robots. Same thing, software from exactly the same software we'd use in gaming, motors, electronics, control, understanding the big system. And my thing really is to all of you, there is a huge range of things you can do in electrical engineering. If you go through your school and you really enjoy chemistry, we need chemists to work on the devices, on the semiconductors, the processors, how we bind all of that together so that we can write this software and put it on something so it can control it. We need mechanical engineers and things around the electric motors. How do we make sure when it starts spinning, it doesn't all fall apart? And we need a lot of work on the electrical engineering across all of these, including in drives. And there is opportunities here in the UK to do that. Why is it important? I think this sort of summarizes it for me. I have one slide after this to sort of wrap up on. This technology, electrical energy, is what is going to underpin net zero. Hopefully you've heard around the activities that were happening in Glasgow in COP26, looking at this carbon, looking at the zero emissions future, looking at how we need to change now to save our world. If we want to make electricity, we've shown you need this type of technology. If we want to use it, we want to use it more efficiently. We want to use less of it. Using less of it is always going to be a good thing. And all of that is driving towards a better world now and the future. And what I would say is that there's a place for everyone. At the moment, there are too many engineers, certainly in the field I work in, that have, whilst exceptionally stylish, a haircut that resembles mine. There is an opportunity for everyone to do everything, wherever you're from, whatever your background, whether you're a boy or a girl, there are opportunities. You can make a difference. And what I would say is things like the activities that we're talking about here, where you can get engaged in that through primary engineering. What a fantastic opportunity. I just wish it had been around when I'd been younger. But it really, I would say, do not think, I can't do it, because of course you can. There is a chance for everyone across all levels doing. If you want to get into manufacturing, we're growing that in the UK. The UK manufacturing is growing. If you want to do the research, if you want to just use it and you want to grow the end users and work, there are opportunities across the thing, and this is not going away. This is the thing that is going to drive what we call net zero ambitions. So whilst I don't at the moment sit there with a soldering iron in my hand, I've been there, done that. And now I'm looking at a sort of bigger picture of how do we move this forward to tackle some of these much bigger pick questions. And I certainly don't have all the answers. And I'm hoping by the end of today, I've got a few more great ideas from questions. So hopefully that gives you a very whistle-stop tour around things. I'd love to answer any specific questions on that. And I'm happy to sort of go into anything that people say, well, that bit was really interesting, we'd like to know more about, and I will do my very best to answer.
Yeah, well, I mean, I've got a few personal questions about what you do, and maybe that'll inspire some of the people who are watching to send a couple more questions through to us as well. I know that you said that you've got a role as a challenge director at the moment, and I know that you said you sort of liaise with a number of other companies and you're in charge of the fund as a whole. Could you drill into that sort of role a little bit more for us so that we can learn a bit more about what it is you do day to day?
Yeah, so on a day-to-day basis, I spend a lot of my time talking with companies in terms of what their technology is, where their technology is going, where does that fit? A lot of companies and a lot of ideas, you have a great idea that you think, this is going to help cars. and then you're focused on this helping cars. When you look at it from somebody who's not as embedded in doing it, you go, well, actually, that would also help planes. You need to talk to the aerospace team. So I spend a lot of time with companies looking at that technology. I spend a lot of my time out talking to companies about what the future can hold. We're seeing all these, I speak to that many companies doing things, bringing that together, boiling that down to, okay, well, I've had 8 people all say this looks to be the future. There's got to be something in that. And then socializing that, and that then allows us to start to work on what we would call foresighting. So looking at what the future might hold, and therefore, what do we need to do to enable that future to happen within the world?
So I remember you mentioning the ISCF, the Industrial Strategy Challenge Fund.
Yeah.
Could you tell us a little bit more about, I suppose, the birth of the ISCF?
Yeah. So ISCF was born out of Theresa May's industrial strategy in 2017, which was delivered through to mid 2020, and that was a big bit of work out of the Department of Business, Energy and Industrial Strategy, aptly named. So what that was looking at grand challenges. So it's looking at, are there 4 or 5 big things we should go after? One of which was clean growth. One of which was decarbonising transport, and those things. And from that, they spawned these challenges that have some autonomy. They're all backed by a business case. So we have to say what we're going to do, why we're going to do it, and then go and deliver it. But we were given, in my case, £80 million of money from government to go and invest in these companies. But across that ISCF portfolio, there are 22 different things ranging from what I'm doing. There's activity in food technology. There is vaccines and medicines manufacture. There is activity on batteries. There is robots, nuclear, energy systems. So what they've then done is take these 5 big things and find key pillars that then support the delivery of the grand challenge, which in turn builds together to give this industrial strategy. And the strategy fund is delivered from the organisation I work for, UK Research and Innovation, which funds the most of the activity that is done in research and innovation within this country from the government side, public sector, and obviously companies invest massively themselves. So it's looking at how we bridge those 2 bits together.
I know that you mentioned that previous to this role, you worked for Ricardo. What sort of made you leave that role and join up for one? I know you said that you're moving on to bigger picture things, but was there something that sort of drove you to think this is exactly how I'm going to help the country and help further engineering kind of thing?
Yeah, I think you hit the nail on the head there. It was I felt that this role I could make a difference, and that's a very big thing for me. How is it that I can make a difference and take roles that, and whilst I was doing that at Ricardo, the opportunity to come and lead something of this scale with the breadth and reach around the whole UK, from Cornwall through to St Andrews, spend a lot of time in South Wales, Northern Ireland. So it is massively broad in that, and it's bringing people together, trying to get this collaboration between different people, different companies, and extracting. And I did my PhD, so I did a doctorate. So I've got an interest in that academic side. How do we extract those as well? And I felt that in this role, I'd be able to work as well to help bridge that. Great research. How do we make it real?
Yeah.
And commercialize it? So I felt that those coming together actually gave me an opportunity to make a bigger difference to the world.
Yeah. I know that obviously negatively affected everybody, but is there specific challenges that arose during the pandemic, and are they still affecting you even now as we move on to nearly the third year of it?
Yeah, so I think that the pandemic brought into sharp relief the importance of supply chains, of how we get product from manufacture to the shops, to people. And that's the same whichever bit of it you look at. And I'm looking very much at that supply chain. How do we ensure we've got a robust supply chain? How do we make sure that we've got resilience there? So if one bit of it doesn't work, we can get stuff still to happen. And I think that sort of raised its head in and during the pandemic. And I think you can see that there's some well-documented things around automotive supply chains at the moment with semiconductors. It also, when it hit, the uncertainty was high. And I think that around industry, if you're running a business and you're there to try and make sure that you can deliver on your objectives and your profit targets, and you make sure you're delivering for your customers, and there's huge uncertainty, you focus on the must-have activities. So we, as a challenge, we changed some of what we did. We ran much smaller competition so that people could get involved, and they were committing for 9 months of doing something, not 3 years.
Yeah.
We ran a competition. Innovate UK ran a very big competition where they fully funded activities. So what we usually do is we put some money in, and the private sector puts some money in. The companies we fund put some money in together to give the whole project. But we actually ran some projects where we would fund the full project up to £50,000 each. So we started to look at different delivery models, and that worked well. There will be, and there will continue to be, casualties of the pandemic. I think that is still to flesh itself out. I think that it's uncertainty in the market, uncertainty as to what's happening, that is more challenging. But what I would say across the things, you look at the things that what is allowing us to come through this is science and technology, the vaccines, the understanding of these variants, how things are then able to make a bigger difference. Those things are delivered out of science, technology, innovation. And I think that is a really strong thing to think, I want to make a difference. I want to do something I can change. Scientists, technologists have done that through this.
Yeah. Is there somebody who inspires you or motivates you? I suppose both when you originally decided to become an engineer and even day to day, is there somebody that you think of when you're making these differences? So
I don't always advise it, but I followed my dad into engineering. He was an electrical engineer, and it was sort of through that I got into engineering from a young age. There's photos of me at 6 sat with a voltmeter on the floor, and that sort of upbringing starts to drive that. And I think what really gets me out of bed in the morning, and I think how does that sort of keep me going on this? It's the feeling of making a difference. Frankly, somebody saying thank you, and actually you did something there that has really made a difference too. That for me is the continual motivation. And that it's got to be from a really big company. It can be anyone. If we can make a difference and help somebody, that's great. And I think things like this, and I go and talk at a lot of events, and I very much have the mindset of, from some of the coaching I had when I started doing this, I've got to enjoy it. And if one other person does, then I've just doubled my success. And in the role, as long as somebody gets something from what I do on a day-to-day basis, whether it's fixing a circuit for somebody, working with somebody on a solution, or whether it's making sure the right people are talking to each other to grow collaboration, that's what's really important on a day-to-day basis.
Yeah, I think it's extremely important that now more than ever, like you say, that we cooperate with the issues with the pandemic and stuff. It's it sounds like, especially with what you do, if you're spearheading a lot of different parts of it, that cooperation is a massive part of your role there, and ensuring that cooperation amongst other people and even nationwide almost, by the sounds of things.
Yeah, absolutely. And I think that cooperation, I think we can't solve things alone. We need a group. If you can have a group of people with a common goal, that's where you get, but you can't equally have, if I put 3 of me going for a common goal, we'll get a much worse answer than 3 different people from different backgrounds and different experiences driving for that.
I remember you mentioned a little bit about the sort of distribution side of it and the manufacturing side. What other sort of aspects of similar things would you look at in trying to achieve what the Industrial Strategy Challenge Fund is trying to achieve? What other parts of that kind of thing would you bring together?
So I think when you look at how all of these different areas work, it's, yes, supply chain, yes, it's how we get that out there. But it is also about how we pull through that research. I think that for me, the strategy challenge funds are all about industrially led. So there's got to be a problem.
Yeah.
We're trying to solve something. We have, and we do, and you can find it's well documented, world-class research in this country, world-class ideas that come out of people, innovators, inventors, got lots of them. How do we pull those through and actually not get great ideas and then they stop because somebody's not funded something? And the Challenge Fund is all about that. It's about supporting market failures. It's about getting the ideas through to market, and it's about growing this public-private partnership between what the government invests through UKRI and what companies do, so we can de-risk some activities as well.
We've got a couple of questions coming through from the people who are watching us at the moment. What inspired you to want to do engineering all the way back at the beginning of it all? Do you remember what it was that sort of made you think this is exactly what I want to do with the rest of my life?
Yeah, so I think, yes, I said my dad was an engineer, and obviously that has a big influence, but I went and did some work experience, and it was all around application of, in my case, drives, so motion control, and it was all about wiring things up, getting things together, making them work, physically seeing the results of what you'd come up with as a solution.
Yeah.
And that was when I did that when I was 15, it's year 10. And that made me go, yes, this is what I want to do. Up till then, I'd enjoyed it. I'd played around. At home, my dad obviously had some components and what have you, and we made some circuits and things like that. So I got that sort of bit. But it was at that point I went, yeah, this is what I want to do.
Yeah.
And then from that went on, and I can see one of the other questions was around A levels and things. So it was at that point I was able to start heading towards that. So for me, I did maths, physics, chemistry, and I also did further maths for my A levels. And I think that if you want to do engineering, I think the maths is really important. I think that of all of them, that for me was doing maths and further maths made the engineering degree easier.
Yeah.
It's the physics was obviously useful, but I think with the maths, you can start to do things. And it depends which branch of engineering, because there's chemical engineering, you'd obviously need a chemistry degree. There's biological engineering. You're going to need, if you wanted to work on engineering and the human body and biomechanics and things, you're going to need to do biology. So I would tailor the area you then say, that's the bit that really interests me, because there's so many to choose from. But I would certainly say the maths is an important one. And it is fun. Believe me, it does get fun by the end, and to actually solve it is very satisfying.
Yeah. we've got a question that says, what do you do when something needs fixing? And I'm not entirely sure if it means
yes. I think this
more.
was the first one, and it popped in while I was talking about wind turbines, I think.
It was, yeah.
So, right. So how do you fix wind turbines? Well, you take a very, very expensive boat out to the wind turbine. And if it's something you can take up, then it's a small fix. You do that. Or you end up having to lower the wind turbine down and deal with it. And either do a full replacement, because it's difficult to fix out at sea, so you might need to replace and fix back on shore. But there's a lot of work ongoing to start to predict when things might fail, so that you can start to fix things or repair things ahead of them actually failing. So there's a huge amount of work in that space to start to look at how do we start to, and also how do we control them to try and extend the life, because we don't want to be out there fixing, but fixing things out there is really hard. So therefore, when we design activities and that sort of thing, we look at it and go, we're actually going to apply more safety factors to this, so we don't have to go out to fix it. It's a very high cost to do that. And also you're losing all the electricity you could otherwise have generated.
Right. Somebody said, can you make things with the items that are around you?
Some things, yeah. I think that what we're seeing, certainly in electronics, is as things shrink, it becomes a lot more difficult to fix things or make things as things get smaller and smaller. But we are seeing, as a result of that, you can get things like a Raspberry Pi, where you can do some coding on it and you can see the outcome of that. You can control things with a Raspberry Pi. You can start to build your own little robots or your own controllers for various things around you. That sort of thing is becoming more and more interesting. Lego now, you can buy Lego that you program and learn to program through that type of thing. But in terms of them building things around you, absolutely, it's still doable. I think a lot of what I've spoke about today is more of it's very highly integrated. So that makes, again, very difficult. But things like Scalextrics, as certainly in my day, Scalextrics and Hornby train sets, you could take apart and fix and put them back together and off you go. And that sort of thing is still doable. Yeah. But even cars, if you open up a car from the early 90s, you can see all the bits of the engine. You can actually do something with it. But things are getting so much more advanced now for safety, for efficiency improvements, that you open the bonnet now and there's a big piece of plastic covering everything. And it's much more difficult to start to do what you could in the past of tinkering.
Do you, I know that the use of electronics is becoming a lot more prevalent in day-to-day life and in things that we all use. But do you use electronics every single time you make something?
I'm trying to think of an example you don't. A sandwich. I'm really, really struggling, because if you want to put something in the microwave, but to have got the bread you needed to bake it, the oven will have electronics in it. If you put something in the microwave, there's electronics in it. If you've got an LED light bulb, it's not just a light bulb, there's electronics in it, and that's power electronics as well. So there is electronics everywhere. That's a great question. And if I'm down to making a sandwich, if you turn a computer on, it's full of electronics. You want to cut the grass. I've never been asked that before. What a great question. I need to think of a better answer to come back to go, well, I have a solution to that. But no, I'm afraid I don't have one.
What is your favorite part about what you do day to day? What is the favorite thing that you get to do? I know that you said the communication and the cooperation aspect is a huge part of it, but is there something that you get to do day to day that just puts a smile on your face?
Yeah, I love to see new technology. I think that whilst I've moved into a much more sort of operational type role, seeing the new technology, understanding it, asking the hard question on, oh, why have you done it that way, or how is it doing that? I think that for me is the really exciting, the inquisitive nature. And you and I would strongly urge anyone that sees things that they're interested in to ask those questions, because anyone that's designed them or invented them would love people to ask the questions. Because often, if you're not a specialist at it, or you're not deeply embedded in doing it, you're going to ask the really simple question that nobody's ever thought of, because they've just assumed this is the right answer. And why have you done it that way? And again, well, it's always been done. Well, that's really interesting. What happens if? Well, I've not even thought of that. And people will love those. So please, everyone out there, when you do see inventions, you go and see how things are working, ask the questions. And certainly engineers would love to talk to you about them and answer those.
And how long have you been an engineer for?
So I've started my degree in 20 years ago. So I did 4 years of degree, and then I did my PhD while doing other bits of work around the side of that. So 20 years ago, I started my degree. So I'm not as old as the haircut shows.
How many hours do you work a day? It sounds like a pretty tireless job that you.
Yeah, I think that varies as well.
Yeah.
I think you do what you need to do when you need to do it. Yes, there's some days that it's early in the morning till late at night. There's other days that actually you're out and about with people, and whilst your time with them is not the full day, it's certainly a full day of activity. But it's one thing that I think we need to look at what gets done rather than how many hours do you do. And I think that some days, I've certainly worked in the past and still been at work at 10:30 at night, 11 o'clock at night. Things need to be done. There's a deadline looming. I've not worked in Formula One, and my understanding is that's even more pressing on that race night. It's a huge amount. So, but it is as what is needed. I think I am contracted on 37 hours a week. So that is 7.5 hours a day. I usually work in and around a few more than that, let's say.
So in the future, what would you like to sort of help create, or to personally create, to sort of link it back in to maybe to try and cover something that the ISCF is trying to fix overall? Is there something that you could see yourself helping with that would be such a major solution, and how would that make you feel to come up with that?
I think for me that the biggest thing that I'm certainly at the moment looking at doing is trying to create more manufacturing jobs for these absolutely critical net zero technologies. I'm not going to be the one to go, yeah, I've solved climate change. I'm not in that gig, but I think that trying to get and play a instrumental part in pulling together that net zero supply chain to allow the UK to lead in that would be a big thing. And I think that in itself is a big ask between now and 2050. So we've still got 30 years to deliver net zero. Obviously, yes. Cars are 2035. We've got a shorter time frame, but we need to be there. And I can see one that's just popped in around what would I like to see in electronics. And I think for me, there, the efficiency. What would I love to see with electronics is really, really high efficiency. We're already up in the high 90s. How do we push that further? How do we make it smaller? How do we use and waste less? Because any efficiency loss is waste. Not only do we have to provide the electricity from somewhere, but it's then wasted usually as heat, which is bad again. So I think that as we go through those, that would certainly be on the electronics where I'd like to see things go.
What is the most exciting thing that you've had the chance to do in your career?
I would probably say I've spent quite a lot of time abroad. And what I really enjoyed was when I went and worked with customers on their sites and things. So I spent a lot of time in Silicon Valley, out there visiting for meetings. I went out to China to visit to meet with customers, as well as India. So working with them, learning from them, as well as giving my expertise into things. I think that for me was the most exciting stuff I did, was those meetings where you can actually meet people face to face you're working with to help solve bigger problems as a team, rather than I myself have got one invention, because I think that is far more powerful.
What would you say the most important thing you've done would be? The thing that's made the most of a difference?
Ooh. I think if we're looking at the most difference to the UK and what we're doing, it's what I'm doing at the moment. Absolutely. I think that has got a huge opportunity there to create big things for the economy. So it's not just it'll create jobs for now and the future. And it's also given me the opportunity to do things like this. We have ring fenced, and it's mainly looking at sort of apprenticeship level and beyond things, but we've got ring fenced £5.7 million to spend on skills to grow the next generation. That to me, if we can deliver that and actually make a difference in there, we're not going to fix the skills shortage. There's a massive skills shortage in this space. So anyone wanting to do this, there's going to be jobs here forever. But if we can make a difference there, that's going to come very, very close. I've just seen one pop up in the Q&A thing just around magnets, and I think that is really relevant.
Yeah.
Are they used in electrical engineering? They are absolutely critical. To make the electricity we use, we need a magnet. We need that magnet to move. And the way that generators work, the magnet moves past or through a coil of wire. And this movement of the magnet past or through the coil of wire creates volts. When we've got volts, we can then create an electric circuit. So these magnets are absolutely critical to make it. Solar power, different ball of it, different idea. But for anything like wave, tidal, wind, magnets. But also high performance electric motors. So you look at the Rolls-Royce recently published a thing where they used an electric plane. They flew a small plane, all electric. And it is likely in there, they've got permanent magnet motors. So the magnets go into the motors and work the other way around to the generator. So you put electricity into your coils and make the magnets move. And these magnets are really important, but they're also quite hard to get. They're made out of materials called or elements called neodymium, dysprosium, and the way we refine those and how we get those is really, really important. So the magnet itself is important. How we get the magnet, I seem to spend a lot of my time at the moment talking about these elements, and they're what are globally called critical minerals, really, really important minerals for the world as we go forward.
Well, what would you say is the most challenging thing about being an engineer?
There's no right answer. There are lots and lots of answers. There are lots of possible answers. And your role as an engineer is to choose the least worst answer. Because it's very, very rare there is one answer, then that's the only answer you can get. It's not like a maths problem. 5 plus 3 is always going to be 8. How do we design a circuit to? How do we design a tower that can? How big should this piece of steel be? Well, it can be this by that, or if you change the shape, it could be this size, or if you change the material you put in, it could be that size. Well, which one's the right answer? It's all about that trade-off, deciding which is doing which. Excuse me, sorry. There we are. Apologies. It's all about those trade-offs between which, is it cost, is it performance, is it weight, is it size? And that, for me, is really exciting, but that's really hard. Because it doesn't matter what answer you come up with, there is another answer that's not wrong. It's just different, and it will have different trade-off properties. That makes it much harder, but also the reason you want to do it, because it's exciting. If it was easy and it was just one answer, it would certainly not be as exciting as it is.
So what would you do if you were unable to solve a problem, and who would you turn to for help?
So that's an absolute belter of a question. And anyone I do interview in the future for engineering roles, that's an interview question I use for job, because to start with, I would probably turn to the person next to me in a work environment, obviously working from home. A little stuck there, but I would turn to the team and I would ask the team, even if I was running the team, what do the team think? It's likely somebody else has come across something similar. I would look for similar examples if nobody has. I'd reach out to the wider people. I say that communication is really important. It's for reasons like this. I'm still in touch with the 2 professors that looked after me when I did my PhD. If there was a power electronics question, I know I can pick up the phone and ask the question. And if all else fails, then we can go back, we can go further back into fundamental research. If it's not known there, then we're going to have to start to consider different solutions and what the trade-offs are, what the benefits are. We can design solutions, but if we don't even know where to start on that, we need to start to look at the question, and are we asking the right question? I want the smallest this. Well, that's fine, but it's going to cost you £4,000. It needs to cost £10. So the question wasn't, I need the smallest this. What you're saying is, I need the smallest one of these for £10. So we need to then also look at, are we asking the right question? And there are going to be some things that are, I'm not going to say impossible, are nearly impossible. And the cost or time to deliver it and develop it would be so massive, you wouldn't do it. So at worst, I'd end up back there.
Yeah. Can anybody learn about engineering?
Absolutely. And there are different, hopefully I've covered this sort of breadth of different things in engineering as well that you can do, whether it's chemical, electrical, mechanical, civil, biological, they're all there. But also there's different activities within those. For an electric motor, we need somebody who's going to design the motor and do a lot of software optimization using some computer software, looking at different solutions, looking at the magnets, looking at the wire. We need somebody who's then going to look at the mechanics of that and go, is it going to fall apart? We need somebody who's going to look at the thermal behavior of that. We need somebody who's going to take that and go, well, to make that, this is what you need, and here's all the drawings. That's all in the design stage. Then we need somebody to make this and assemble it and test it and feed all the output from that back. But then somebody's going to integrate it into a bigger product. So if you take a car motor, it gets made up to the motor. It then gets put usually inside a transmission. And then the transmission gets put up into the car. So there's different people at different stages. And that was just with the motor example. So if what you say is actually, I want to be hands-on, I want to be looking at different ways we can test motors. So we test them in less time. So it's more efficient. We can sell more products and make more profit. great, there's a job for that. If you go, I want to be there and look at how we stamp laminations to make these motors better, there's a job there. If you want to design it, there's an opportunity.
So just a few more questions and then we'll close up, so we're not using up too much of your time. But I am interested, what kind of industries are helping to further these goals that you're working with nationwide?
So we're quite unique from a challenge perspective that we work across everything that uses motors and power electronics. But the sort of key sectors, certainly automotive is leading the way with the removal of internal combustion engines, very much on the horizon. But aerospace is becoming more prevalent. That obviously for very short haul, electric. And I mentioned earlier, Rolls-Royce had recently put their Spirit of the Air aircraft and done some press on and around that. So that can be found using any good search engine. But the other ones, rail. I was lucky enough that I was able to go up to Bowness, just north of Edinburgh, a month or so ago, and they're looking at a hydrogen train solution to operate on the lines into the rural parts of Scotland, where electrification is very difficult, and you would end up putting in overhead lines and all this that was not cost effective and environmentally probably not the right. So they looked at a hydrogen solution. So, but for that, they need the hydrogen, the fuel cell, but they still need the electronics and the motors and everything else down the line from that. So they're looking at marine. There's a big amount of marine activity, surprisingly, around how do we have zero emission marine or low emission or using different fuels. And the same in things like the off-highway sector. How do we, all the JCB, Caterpillar, John Deere, other brands are available, machinery are looking at decarbonising as well. So there's all that on top of the more conventional things I talked about earlier with drives and robots and all that, which are already electric. And I think it goes without saying, all underpinned by a green energy network as well.
Why is the work that you do with the ISCF so important to the UK and to everybody that lives here?
We are net zero is required.
Yeah,
I think we have to acknowledge that, and that is something that's come out of everything being looked at. And if we just sort of focus on the net zero piece and what we're looking at, if we don't continue to invest in that, we're going to either lose the research and it'll just be sat on a shelf, which means there are ideas that won't be furthered, or we'll end up importing everything. And net zero is here to stay. We've got great inventions, great inventors. We need to then be able to work with them to secure prosperity. So by that, I mean jobs, I mean money to stay in the country to make that difference. But it's also about how we can use these good ideas. And I think that that's the bit we need to keep the good ideas coming. We need to invest in them, and we need to work with our companies to make a difference. Because if we leave it to natural, I think probably the better way is if other countries are investing in this as well. So this isn't a unique, the UK is investing here. If we didn't invest, we would be at a global disadvantage for this technology. There is a huge and growing market for it. We're not going to be the only one in there. We don't need to be the only one in there. The market itself is big enough, but we need to be in the game to prosper from the transition to net zero.
Right. I suppose one final question before I do a little bit of a closing statement. If you had one piece of advice for the people watching who wanted to become an engineer, what would it be?
Do what you enjoy. Go out there, find out about what you enjoy, try things. No question is stupid. Ask as many people as many questions as you want. and you can do it. Some of the best inventions have come out from people not realizing that that's what they were doing. But you can do it. There's a role for everyone, and there is such a diverse area in engineering, even within the little bit I look at. Find out what you enjoy, do what you enjoy, because you're going to be doing it for a while, and just go for it. Ask questions.
Right. And on that note, I do apologize for having to cut this short because I'm having an amazing time talking. I know from some of the questions, as you said, they've been really inspiring, even for these who's an engineer compared to some of our viewers. But I don't want to keep you from your amazing work any longer. I do hope you've enjoyed your time here with us as much as I've enjoyed spending it here with you. I hope that everybody who's been watching has had an amazing time watching this once in a lifetime chance at interviewing a guest like this. Thank you again, Will, for joining us today. It's been a real pleasure chatting with you about your work.
Fantastic. No, really enjoyed it. Thank you all very much. And if there's anything I can do for anyone and just pointing you in other directions, always happy for people to reach out through you to me.
Well, yeah, right. All the teachers watching, remember you can access all the resources that you need for the project on www.leadersaward.com. Every Wednesday at 1:30, we'll be doing another one of these. I think we're reconvening on the week commencing the 3rd of January. Make sure that you catch all of the ones that we've already taken part in on youtube.com/primary engineer in a few days. This one will be uploaded as well. But otherwise, goodbye to everybody, and I hope you have a lovely day and happy engineering.